Volcanoes. They are among the most awe-inspiring yet terrifying forces on the planet. From the fiery eruptions that spew molten lava across the landscape, to the quiet rumblings beneath our feet that signal a looming disaster, volcanoes have a story to tell that is as captivating as it is alarming. For millions of years, these geological giants have shaped the Earth, creating both breathtaking beauty and devastating destruction. Today, we will explore this dual nature of volcanoes, focusing particularly on those that could potentially bring humanity to its knees. But first, let's dive into the basics of how these magnificent yet fearsome structures operate. Volcanoes form at tectonic plate boundaries where the Earth's crust is thin or fractured. As pressure builds from molten rock, or magma, deep beneath the surface, it seeks a path to release. When it finally erupts, it can unleash an unimaginable force. The 1991 eruption of Mount Pinatubo in the Philippines is a perfect case study. This eruption released 20 million tons of sulfur dioxide into the atmosphere, which caused global temperatures to decrease by about 0.5 degrees Celsius for 2 years. Imagine the implications of such an event happening on a much larger scale. But what exactly constitutes a supervolcano? Supervolcanoes are massive volcanic systems capable of producing explosive eruptions thousands of times more powerful than typical volcanoes. Take the Yellowstone supervolcano, for instance. It has erupted 3 times in the last 2.1 million years, with the last massive eruption occurring approximately 640,000 years ago. If Yellowstone were to erupt today, the consequences could be catastrophic, not just locally, but globally. The ash cloud would disrupt air travel across the world and cover large swaths of the United States in a thick layer of ash, burying cities and farmland alike. The ash fallout could lead to a volcanic winter, drastically reducing sunlight and cooling the planet for years to come. Even more alarming is a lesser-known supervolcano, Toba in Indonesia. Its eruption around 74,000 years ago is believed to have caused a volcanic winter that lasted for several years, drastically affecting the Earth's climate and leading to what some researchers propose was a near-extinction event for early humans. The reality is, we live in an age where technology allows us to monitor these volcanoes closely. But regardless of our advancements, the unpredictability of nature remains a constant threat. What can we do to prepare? Understanding volcanoes is the first step. In the following chapters, we will delve deeper into specific volcanoes that could potentially end civilization as we know it, analyzing their eruption histories, current activity, and what we can learn from our past to protect our future. But before we move on, it's essential to acknowledge the profound respect we must hold for these geological giants. With the knowledge that awaits in the subsequent chapters, gather your thoughts and ready yourself for what is to come. Because the real questions remain, will we be prepared when the Earth decides to remind us of its power? Yellowstone National Park has long been a beacon for nature enthusiasts and tourists alike. However, beneath its stunning landscapes and thermal features lies a geological beast, the Yellowstone supervolcano. It's hard to believe that this breathtaking park sits atop one of the largest active volcanic systems on the planet. The last major eruption occurred approximately 640,000 years ago, releasing an estimated 1,000 cubic kilometers of material into the atmosphere. But the reality is, Yellowstone is still very much alive. Today's scientists use a plethora of monitoring techniques to assess volcanic activity, including ground deformation measurements and seismic monitoring. Recurrent uplift and subsidence, as observed since 2004, indicate that magma is slowly moving beneath the surface. This has raised alarms about the supervolcano's potential to erupt again. In 2019, researchers detected a large fracture in the ground near the park, further emphasizing the caution required when dealing with this geological giant. But what if Yellowstone were to erupt today? Experts predict that the ash fallout could spread as far as the east coast of the United States, affecting millions of lives and the agriculture industry, the very backbone of our economy. This eruption would block out sunlight, thrusting the Earth into a volcanic winter and disrupting global climate patterns. The implications of Yellowstone's potential eruption are staggering. According to a study by the U.S. Geological Survey, the economic cost of such an event could exceed $1 trillion, with a staggering toll on human lives and infrastructure. Notably, the Toba eruption 74,000 years ago serves as a grim reminder of the possibility of a supervolcano wiping out humanity as we know it. In fact, genetic research suggests that humanity suffered a population bottleneck around this time, hinting that the eruption may have drastically reduced the number of humans on the planet. Meanwhile, the geologic evidence shows that Yellowstone has experienced numerous eruptions in the past, and the geological record hints that the next one could happen sooner than we expect. So what can we learn from Yellowstone? First, it illustrates the importance of monitoring and understanding our environment. As experts continue to research the supervolcano, they remind us that preparedness is key. It's not about if it will erupt, but when. However, with knowledge comes power. We can develop contingency plans and improve our resilience against potential catastrophes. The challenge lies in convincing the public of the scale of the threat. The Yellowstone supervolcano is both a marvel of nature and a formidable threat. As we continue our journey through the world of volcanoes, we will soon turn our focus to another massive supervolcano, the Campi Flegrei in Italy. This phenomenon could potentially rival Yellowstone and has its own complex narrative that you won't want to miss. Nestled near the vibrant city of Naples, Italy, lies Campi Flegrei, one of the most dangerous supervolcanoes in the world. This caldera is not just a single volcano, it is a complex of numerous craters, eruptive vents, and geothermal features that have shaped this unique landscape. The last major eruption occurred around 39,000 years ago and is believed to have created a cataclysmic event, resulting in the devastation of the surrounding area. As with Yellowstone, scientists closely monitor Campi Flegrei for signs of activity. Since the late 20th century, the ground has been slowly rising, indicating the accumulation of magma beneath the surface. This uplift has raised concerns about the potential for another major eruption. Some researchers even propose that a large-scale eruption could lead to a disaster that would impact not just Italy but much of the Mediterranean region and beyond. The eruption of Campi Flegrei is not only a geological concern, it poses a psychological one too. Despite the dire warnings, the residents living in close proximity have become accustomed to the quiet hum of this geologic time bomb. One recent study indicated that many locals are unaware of the potential risks, which complicates evacuation and preparedness plans. But what would happen if Campi Flegrei erupted today? Experts suggest that the consequences would be catastrophic. Ash clouds could extend across Europe, grounding flights and affecting air quality for millions. Additionally, significant segments of the Italian population could be at risk, leading to large-scale evacuations and loss of life. The historical account of Campi Flegrei reveals that eruptions have had devastating impacts on both the local and global climate. Much like the eruptions of Toba and Yellowstone, it has the potential to create a volcanic winter effect. As we learn from the historical context, the residents must embrace a culture of preparedness. Understanding the risks and potential consequences can help foster a more resilient community. In this chapter, we learned that the threats posed by Campi Flegrei are very real. The danger is not just from eruption but from the complacency of residents who live in this beautiful but dangerous landscape. As we move on, the next chapter will take us across the globe to one of the world's deadliest volcanoes, the supervolcano beneath the city of Naples. We will examine its impact on society and its potential to disrupt modern life as we know it. Underneath the bustling streets of Naples lies a dormant giant, a supervolcano that remains a significant threat to the city's 3 million inhabitants. Despite the vibrant culture and rich history of this region, the fires of the past still lay beneath, reminding us that no location is truly insulated from nature's fury. The Campanian volcanic arc, where Naples is located, has witnessed several eruptions throughout history, including a major catastrophic eruption 15,000 years ago. The impact of a sizable eruption today would be unimaginable. Experts estimate that an eruption could unleash 100 times the ash produced by the Mount St. Helens eruption in 1980. The ash cloud would disrupt air travel, bury homes, and obliterate agricultural lands critical to southern Italy's economy. But it's not just the immediate effects that pose a risk. The long-term consequences could potentially alter the climate of the entire region. Historical records show that eruptions have led to global cooling trends, similar to what we observe from previous supervolcanic eruptions. The potential for widespread crop failures and food shortages would exacerbate social tensions and lead to widespread panic. In recent years, researchers have focused on understanding the potential threats posed by this supervolcano. They have pioneered techniques to assess underground magma movements and predict the next eruption, including remote sensing and satellite imaging. In 2016, scientists published a study indicating signs of unrest beneath the volcanic structure, leading to increased scrutiny of the area. The densely populated cities surrounding the supervolcano are particularly susceptible to disruption. As we have seen in recent disasters, urban centers are less resilient to natural calamities, often leading to tragic outcomes. With millions at risk, how are local authorities preparing for this potential disaster? Interestingly, while the volcanic threat appears imminent, many locals maintain a sense of normalcy, often dismissing the warnings of scientists. This complacency could lead to disastrous consequences should an eruption occur. As we conclude this chapter, we must reflect on the fragile balance of life in the shadow of a supervolcano. Understanding the potential of our natural world helps us navigate the risks we face, as we prepare to confront the next stories of explosive potential in our exploration of the volcanoes that threaten civilization. As we stand on the brink of understanding the vast potential of volcanoes, it is critical to recognize not just their local effects but their global repercussions. When a volcano erupts, it sends ash and gases high into the atmosphere, where they can have far-reaching effects on climate, air quality, and even human health. One of the most notable cases in recent history is the eruption of Mount Eyjafjallajökull in Iceland in 2010. This relatively small eruption caused a significant disruption in air travel across Europe, grounding more than 100,000 flights and affecting millions of people. It serves as a stark reminder of how even a localized volcanic eruption can lead to global consequences. Moreover, volcanic ash is not just a nuisance, it poses real hazards to aviation and public health. Fine ash particles can cause respiratory issues, while the larger particles can damage aircraft engines. In addition to immediate impacts on human life, ashfall can lead to environmental disasters. The Toba supervolcano's eruption is a prime example of this. It is believed to have contributed to a global drop in temperatures, potentially instigating a volcanic winter that lasted for several years. The interplay between volcanic activity and climate change raises critical questions about our planet's future. How can we adapt to these changes, especially when our activities contribute to climate instability? In summary, while we often focus on the local devastation caused by volcanoes, we must also consider their global implications. As we continue our exploration of the world's most fearsome volcanoes, there remains a critical need for awareness, preparedness, and research to ensure that we are ready for whatever comes next. Our journey through the volatile world of supervolcanoes reminds us of our vulnerability and the important lessons learned from history. In the next chapters, we will explore other volcanic threats, including those lesser known yet equally formidable. Stay tuned as we peel back the layers of danger that linger beneath the surface of our planet. In the annals of history, the eruption of Mount Tambora in 1815 stands as a monumental event that reshaped the planet. Known as one of the most powerful volcanic eruptions recorded, Tambora catapulted an unimaginable amount of ash and sulfur dioxide into the stratosphere, resulting in what historians have dubbed the year without a summer. Imagine waking up to skies choked with ash, crops failing, and famine spreading like wildfire across continents. This eruption, located on the Indonesian island of Sumbawa, spewed forth an estimated 100 cubic kilometers of material, a force that would have been catastrophic had it occurred near a major urban center today. The eruption reached a volcanic explosivity index, VEI, of 7, on a scale where 8 signifies a supervolcano. To put this into perspective, Mount St. Helens eruption in 1980 had a VEI of 5. The climate anomalies following Tambora's eruption led to severe temperature drops across the northern hemisphere, disrupting weather patterns and leading to widespread crop failures. The repercussions extended beyond mere agriculture. In the United States, the eastern states witnessed a snowfall in June, while in Europe, the cold temperatures led to widespread food shortages. An estimated 90,000 people perished as a direct result of starvation and related diseases within the year. The societal impacts of this eruption were profound. The desperation and hardships led to heightened tensions across Europe and North America, contributing to migrations and even revolutions. The perfect storm of crop failures and economic turmoil led to the rise of social unrest, highlighting how interconnected and fragile our civilizations truly are. If a supervolcano like Tambora erupted again today, the effects would be magnified exponentially, considering our much larger global population and reliance on technology. Scientists are particularly concerned about the potential for similar eruptions in the future, especially understanding supervolcanoes and their eruption mechanisms. With climate models continuing to evolve, researchers are continually revisiting historical eruptions to predict future patterns. Tambora remains a cornerstone case study for understanding volcanic risks and preparedness. As we examine past eruptions, the question remains, how prepared are we for another catastrophic volcanic event? Are we even acknowledging the signs? With rising global temperatures and increasing volcanic activity across several hotspots, the possibility of another eruption like Tambora is not just a relic of history, it's a wake-up call for humanity. What if the next eruption doesn't just disrupt agriculture but threatens our very infrastructure? What measures are currently in place, and how can we improve them? The answers lie ahead as we delve deeper into our understanding of volcanoes in the following chapters. Predicting volcanic eruptions has been one of the most elusive challenges for scientists. In the digital age, with advanced modeling and geographical data at our fingertips, you might think we have all the answers. But the reality is that the science of eruption prediction is fraught with challenges. Volcanologists use various methodologies to monitor volcanoes, including seismic activity, gas emissions, ground deformation, and thermal imaging. Each of these techniques provides critical data, but none can guarantee a prediction with absolute certainty. Seismic activity, for instance, is a primary indicator. When a volcano begins to erupt, it often produces numerous low-frequency earthquakes. These can start days, weeks, or even months before an eruption. Scientists analyze the intensity and frequency of these quakes to assess the likelihood of an impending eruption. Take the 2009 eruption of Mount Redoubt in Alaska as an example. Leading up to the eruption, seismic activity increased significantly, and scientists were able to alert local residents before the explosion, averting potential disaster. However, predicting eruptions based solely on seismic activity can be misleading. Some volcanoes may exhibit little warning before erupting. The 1986 eruption of Mount St. Helens, which violently transformed the landscape, produced seismic signals that were detectable only a short time before the eruption. The unpredictability remains a core challenge. Moreover, gas emissions offer another window into the volcanic activity. Volcanoes emit a variety of gases, like sulfur dioxide and carbon dioxide. By closely monitoring these emissions, scientists can gauge the volcano's behavior. High levels of sulfur dioxide, for instance, can indicate magma movement towards the surface, often foreshadowing an imminent eruption. Ground deformation, too, is a crucial indicator. When magma accumulates in a volcano, it creates pressure, causing the surface to deform. Instruments like GPS and INSAR, interferometric synthetic aperture radar, help scientists accurately measure these changes in real time. But despite all these advancements, the reality remains: there are still no foolproof methods to predict eruptions accurately. Each volcano has its unique fingerprint, making it incredibly difficult to create a universal prediction model. The need for greater understanding and collaboration among scientists worldwide is essential. As we march deeper into the 21st century, the environmental changes we face may alter volcanic activity in unexpected ways, making our current data inadequate. As we push the frontiers of this knowledge, we must ask ourselves, will advancements in technology allow us to predict when the next catastrophic eruption may occur? How can we bridge the gap between what we know and the unpredictability of nature? We will explore the connection between climate change and volcanic activity next, as we examine how Earth's warming may influence future eruptions. As our planet's temperatures rise due to climate change, we find ourselves at the crossroads of environmental disaster and geological unpredictability. Studies have begun to suggest that climate change could actually influence volcanic activity, potentially increasing the frequency and severity of eruptions. The concept might seem baffling at first. How can a warming planet, with melting glaciers and rising sea levels, impact volcanoes? The answer lies in the delicate interplay between the climate, Earth's crust, and tectonic activity. As glaciers and ice sheets melt, they reduce the weight pressing down on the Earth's crust. This release of pressure can lead to increased volcanic activity. In regions like Iceland, where massive ice caps are retreating due to rising temperatures, the relationship between glacial melt and volcanic eruptions has garnered significant attention. Take the 2010 eruption of Eyjafjallajökull as a case study. Its explosive eruption was directly linked to the melting of ice covering the volcano. The melting ice created opportunities for magma to rise rapidly, leading to a catastrophic explosion. The ash cloud it produced disrupted air travel across Europe for weeks, a reminder of how interconnected our world is. Moreover, scientists are studying volcanic eruptions' global impacts on climate, particularly the cooling effects of ash and gas emissions. The 1991 eruption of Mount Pinatubo, for instance, released sulfur dioxide into the stratosphere, resulting in a temporary global cooling of about 0.5 degrees Celsius. As we continue to confront climate change, the potential for volcanic eruptions to exacerbate existing environmental conditions raises alarm. Extreme weather events caused by climate change could create conditions for eruptions to trigger. For researchers, this creates a troubling paradox. How do we prepare for volcanic eruptions in a changing climate? As volcanic activity may become more unpredictable, the existing methodologies for monitoring and predicting eruptions may require reevaluation. The interconnections between climate and geological events cry out for urgent attention. The focus on climate change must also encompass the geological implications as we face a future that could very well include more frequent eruptions. As this chapter closes, we are left with an unsettling thought. Will our world be ready for the onslaught of nature's fury as our climate continues to change? In the next chapter, we will dive into how communities can respond to these looming threats and what measures are in place to prepare for a possible volcanic catastrophe. As we acknowledge the looming threat of volcanic eruptions, the next critical step is preparation. How do communities, governments, and scientists work together to mitigate the risks associated with volcanic activity? Preparedness begins with education. In volcanic regions, residents must be educated on the signs of an impending eruption and the necessary evacuation procedures. In places like Hawaii, where Kilauea frequently erupts, communities engage in regular drills to prepare for possible eruptions. Governments play a vital role in establishing effective emergency response protocols. They often rely on local volcanologists and geological surveys to provide timely and accurate information. Successful evacuation plans, clear communication systems, and well-defined disaster response strategies are essential. In regions like southern Italy, where Campi Flegrei poses a significant risk, officials have established detailed evacuation routes and safety zones, ensuring communities are ready to act swiftly in the face of danger. But preparedness goes beyond immediate response. It encompasses long-term strategies, including land use planning and infrastructure development. Building codes in high-risk areas must be revised to withstand potential volcanic activity, ensuring that structures can endure ashfall, lava flows, and earthquakes. Additionally, monitoring systems must be refined and adapted. Countries like Japan and the United States have developed sophisticated early warning systems to alert communities of danger. These systems combine real-time data from various monitoring techniques, enabling timely evacuations and minimizing loss of life. Moreover, community resilience is essential. A well-informed public can adapt to emergencies, support neighbors, and participate in disaster response. The role of social networks in disaster recovery cannot be underestimated. Communities that foster strong ties can bounce back more quickly from crises. With climate change, the unpredictability of eruptions increases. Preparedness must evolve in tandem, addressing new challenges and incorporating the latest scientific findings. It is a daunting task, but we have seen communities come together in the face of adversity. As we look to the future, the question remains, are we truly ready for what nature may throw at us? Will we have the necessary resilience to withstand not just volcanic eruptions, but a myriad of interconnected disasters? In our final chapter, we will reflect on what volcanoes teach us about our existence and the fragility of our civilization. As we draw our exploration of the volatile world of volcanoes to a close, it is essential to reflect on the lessons they impart regarding humanity's resilience and fragility. Volcanoes remind us of the power of nature, illustrating how quickly our lives can be upended. Throughout history, eruptions have not only shaped the landscape but also catalyzed social change. They serve as mere reminders that human beings, despite our technological advancements, are still vulnerable to the forces of nature. When Tambora erupted in 1815, it didn't just alter weather patterns, it reshaped societies, triggering migrations and revolutions. Such far-reaching impacts remind us that we are part of a complex web of life where ecological balance is crucial. In facing potential volcanic catastrophes, we not only need technology for monitoring but also a robust framework for community engagement and education. In places like Indonesia, local knowledge is a powerful tool. Indigenous communities have preserved insights that can be invaluable for modern disaster management strategies. However, it's imperative that we do not view volcanic eruptions as solely threats. They also offer fertile soils that support agriculture and contribute to the planet's biodiversity. Our relationship with these giants must embrace both respect and understanding. As we move into an uncertain future marked by climate change, scientists and communities must collaborate to bridge the gaps in our understanding of volcanic behavior. The potential for eruptions to occur unexpectedly at any time means we must maintain a state of preparedness and adaptability. Just as the Earth shifts and changes, so too must our strategies for response and recovery. If we can learn from past eruptions, we can build a resilient society that understands the importance of preparing for the worst while celebrating the best. Ultimately, volcanoes serve as stark reminders of our place in the universe. They teach us about the cycles of life and death, destruction and regeneration. In confronting the very real possibility of eruptions that could disrupt our civilization, we must embrace the challenge with a spirit of resilience. In our final thought, as we gaze into the fiery hearts of these mountains, we should also look within ourselves and ask, are we ready to confront the inevitable challenges ahead? That readiness, forged in understanding and cooperation, may very well be the key to our survival. As we conclude, remember that our survival hinges not only on our ability to predict and prepare but also on our capacity to learn, adapt, and unite in the face of nature's fury. This journey into the hidden power of volcanoes has revealed much about our world and ourselves. What will be the next chapter for humanity in the face of such undeniable forces? The term supervolcano often conjures images of apocalyptic clouds and fire raining down from the skies. Yet, the reality of supervolcanoes is more nuanced and complex than many understand. While it's easy to let our imaginations run wild with fantasies of destruction, the truth is that supervolcanoes are not just about catastrophic eruptions. They are geological features that have shaped our planet in more ways than one. Let's start by defining what a supervolcano truly is. According to the United States Geological Survey, a supervolcano is defined by its capacity to erupt more than 1,000 cubic kilometers of material in a single eruption. Examples include the Yellowstone caldera in the United States and Campi Flegrei in Italy, both discussed in our previous chapters. Historically, when supervolcanoes erupt, their impact is not localized. The gigantic ash clouds they produce can travel thousands of miles, affecting weather patterns and climate for years to come. Take the eruption of Mount Tambora in Indonesia in 1815, which produced the infamous year without a summer in 1816. Temperatures plummeted, global harvests failed, and food shortages followed. This shows how interconnected our world is. An event that happens in one part of the globe can have repercussions felt everywhere. Yet, myths also exist around supervolcanoes that need addressing. Many believe that the eruption of a supervolcano is imminent at any moment. This is largely exaggerated. Statistically speaking, the likelihood of a supervolcano erupting this century is less than 1 in 100. Scientists continuously monitor these areas with cutting-edge technology, looking for signs of unrest. Moreover, the perception of supervolcanoes often makes them seem like ticking time bombs. But understanding the science behind them can alleviate some of that anxiety. For instance, many people picture a massive explosion akin to a nuclear bomb, creating an enormous crater and sending ash into the atmosphere. Yet, supervolcano eruptions can also occur through effusive eruptions, which are not destructive at all but can still reshape the landscape. We must also consider the resilience of life itself. Geothermal landscapes, created by supervolcanic activity, often nourish unique ecosystems. For example, areas surrounding Yellowstone boast diverse wildlife, all thriving in what is often termed a geological miracle. So, while the potential for catastrophic eruptions certainly exists, they also have an important role in shaping ecosystems and geology. As we continue to learn and research, we will uncover more about these fascinating giants beneath our feet. This knowledge plays a crucial role in balancing the narrative between fear and understanding. As we conclude this chapter, it's essential to remember that knowledge is our best ally against the myths and fears surrounding supervolcanoes. Understanding their behavior and the natural world around us equips us to face whatever comes next, from natural disasters to the wonders of the earth itself. In the next chapter, we'll explore a lesser-known volcano that has the potential to be just as catastrophic, yet remains shrouded in mystery, the Toba supervolcano. Its history and future implications are essential for understanding the global volcanic landscape. When we think of volcanic eruptions, most of us picture molten lava spewing into the air, massive ash clouds blocking sunlight, or a deafening explosion. However, few consider the dangerous gases that permeate these eruptions. The gases emitted by volcanoes are not only a fascinating aspect of volcanology but also a potential threat to civilization. Volcanoes emit gases such as sulfur dioxide, carbon dioxide, and water vapor. Among them, sulfur dioxide is particularly concerning. When released into the atmosphere, it can lead to acid rain and contribute to climate change. In high concentrations, it poses direct threats to human health and ecosystems. For example, the 1986 eruption of Lake Nyos in Cameroon released a colossal amount of carbon dioxide, suffocating nearly 1,800 people and livestock in a wave of gas that flowed down the mountain slopes. While volcanic gases are often overlooked, they can profoundly alter the climate. In the case of the Pinatubo eruption in 1991, sulfur dioxide injections created a haze that cooled the planet by almost 1 degree Celsius for several years. This illustrates how a single volcanic event can have some of the most substantial effects on global weather patterns, disrupting agriculture, and creating food shortages. The research into volcanic gases has also expanded in recent years. Scientists use remote sensing technologies to study gas emissions, allowing them to predict eruptions more effectively. They utilize satellite data to monitor sulfur dioxide levels, giving early warnings to populations living near eruptive volcanoes. For instance, in 2018, the Kilauea volcano in Hawaii displayed increased gas emissions before its eruption, allowing residents to evacuate and avoid disaster. But the study of volcanic gases extends beyond mere prediction. Understanding the composition of these gases can provide insights into the Earth's mantle, helping us unlock the secrets of our planet's geology. Volcanologists can trace the sources of magma by analyzing gas bubbles trapped in rocks. This not only aids in eruption prediction but also serves as a window into the Earth's past. As we delve deeper into the implications of volcanic gases, we start to grasp the vital connection between geology and climate science. The gases released can lead to both short-term and long-term changes in our environment. These changes can influence policies on climate adaptation and disaster preparedness, showcasing how interconnected our modern world truly is. As we wrap up this chapter, it's evident that while we gaze into the fiery depths of volcanoes, we must also pay attention to the unseen. The gases venting from their depths are not just silent killers, they are key indicators of what lies beneath and what might surface next. In our next chapter, we will take a look at the future of volcanic research, exploring innovative technologies that promise to revolutionize how we understand and interact with these powerful geological phenomena. As we look to the future, the field of volcanology is on the brink of a technological revolution that could dramatically change our understanding of volcanic activity and how we respond to it. Advanced technologies are beginning to offer unprecedented insights into the behavior of these geological giants. One of the most exciting advancements is the integration of artificial intelligence and machine learning in volcanic research. Machines can analyze vast datasets far quicker and more efficiently than humans. They can sift through historical eruption records, seismic data, and gas emissions to identify patterns that might indicate an impending eruption. A case in point is the work being done at the University of Bristol and the British Geological Survey, which employs AI to predict eruption probabilities effectively. Another breakthrough is the use of drones and unmanned aerial vehicles, UAVs, in the study of volcanoes. As previously mentioned, remote sensing is critical for understanding volcanic gases, but drones can gather data in real time from vantage points that are otherwise dangerous or impossible to access. This ability allows researchers to monitor volcanic gases, thermal activity, and even the structural integrity of volcanic formations. For instance, during the 2018 Kilauea eruption, drones provided invaluable data that helped inform evacuations and safety measures. Moreover, satellite technology has advanced significantly. The European Space Agency's Sentinel-1 satellites use synthetic aperture radar to detect ground deformation, an essential indicator of volcanic unrest. This offers a broader view of volcanic monitoring, helping us to not only predict eruptions but also understand the longer-term shifts in volcanic landscapes. Meanwhile, advancements in geochemical analysis techniques are allowing scientists to gather minute details about magma compositions. The availability of portable mass spectrometers means that geologists can analyze volcanic gases on site, giving them immediate insights that can be crucial during an eruption. As we gaze into the future, we must also consider the implications of these technologies. Will enhanced understanding lead to better preparedness, or will it foster complacency among vulnerable populations? The balance between fear and knowledge is a delicate one, requiring not just scientific understanding but also effective communication with the public. In summary, emerging technologies are set to redefine our relationship with volcanoes. Armed with AI, drones, and advanced geochemical tools, we are on the frontier of a new era in volcanic research. The potential to predict eruptions and mitigate their impacts could transform our approach to living alongside these powerful natural forces. Next, we will discuss how education and community preparedness can serve as the final piece in the puzzle of coexisting with supervolcanoes and other volcanic threats. What if everything you thought you knew about supervolcanoes was wrong? The term supervolcano might send chills down your spine, but many myths surround these geological giants. Some believe that a supervolcano eruption could wipe out humanity entirely, while others downplay their risks. But what is the truth? In this chapter, we will dismantle popular myths surrounding supervolcanoes and dive into the scientific facts. One myth suggests that all supervolcanoes erupt with catastrophic force, leading to global extinction. While it's true that the last significant eruption from Yellowstone occurred around 640,000 years ago, not every supervolcano is due for an explosive eruption. For instance, research shows that Campi Flegrei eruptions can range in intensity, with some only producing minor activity. Many people think supervolcano eruptions happen suddenly, without warning. However, volcano monitoring has improved immensely. Scientists often detect precursor activities, such as seismic changes and ground deformation. The next myth tackles the idea of ash being the only threat from eruptions. It's easy to picture the ash cloud as the sole villain, but that's just one part of a much larger story. Volcanic gases like sulfur dioxide can remain in the atmosphere for years, contributing to acid rain and climate change. In fact, it's these gases that could have a more significant impact on global climate than the ash itself. Most importantly, the myth that humans have no means to prepare is perhaps the most dangerous of all. Various organizations worldwide are actively working on emergency preparedness plans and education initiatives. This chapter serves as a reminder that knowledge is power when it comes to the imminent threat of supervolcanoes. As we embrace the truths about these geological wonders, the road ahead is not defined by fear but by a commitment to understand our planet better. And as we close this myth-busting chapter, the question looms: what new challenges might arise from the powerful forces beneath our feet? While lava flows and ash clouds are often the focus of volcanic eruptions, there's another hidden threat lurking beneath the surface: volcanic gases. These silent killers can have catastrophic effects on human health and the environment. In this chapter, we will explore the complex world of volcanic gases, the science behind them, and the devastating impacts they can have. Volcanic gases primarily include water vapor, carbon dioxide, sulfur dioxide, and a mix of other gases. The concentration of these gases can vary dramatically and is crucial in determining the risk associated with a volcanic event. For example, during the 1986 Lake Nyos disaster in Cameroon, a sudden release of carbon dioxide from the lake led to the death of nearly 1,800 people. This horrifying event revealed how dangerous volcanic gases can be, even if they're not erupted in the traditional sense. As we study gases released by volcanoes, we find that sulfur dioxide is particularly concerning. When released into the atmosphere, sulfur dioxide can lead to acid rain, which can devastate ecosystems and contaminate water supplies. Moreover, the interaction between volcanic gases and climate change can have long-term global impacts. Researchers are exploring how gases released from supervolcanoes like Yellowstone could influence atmospheric conditions, ultimately altering weather patterns. As we dive deeper into the science of volcanic gases, we uncover the importance of monitoring these emissions. Continuous monitoring systems are crucial for early detection of dangerous gas concentrations, providing vital information to public health officials and local communities. The story of how Indonesia's Mount Sinabung became a case study for gas monitoring illustrates the importance of proactive measures. Following its reawakening in 2010, scientists developed a gas monitoring system to assess risks and advise villagers on potential evacuations. As we conclude this chapter, remember, the real power of volcanoes lies not only in their eruptions but also in the gases they silently emit, posing threats we must be prepared to face. As our understanding of volcanoes evolves, so too does the technology we use to study them. In this chapter, we explore the innovative advancements that are revolutionizing volcanic research, making it possible to predict eruptions and minimize risks. The use of drones has taken volcano monitoring to new heights, quite literally. Equipped with cameras and sensors, these unmanned aerial vehicles can access hard-to-reach areas, capturing real-time data on gas emissions, thermal activity, and ash dispersal patterns. For instance, researchers studying the Kilauea volcano in Hawaii implemented drone technology to monitor eruptions, significantly improving their ability to assess changes in volcanic activity. Additionally, thermal imaging cameras have become a staple for volcano scientists. These cameras can detect changes in temperature that might indicate magma movement beneath the surface, offering invaluable insights into potential eruption risks. But technology doesn't stop there. Researchers are also using machine learning and artificial intelligence to analyze vast datasets from numerous monitoring stations worldwide. By employing advanced algorithms, scientists can identify patterns and make predictions about future volcanic behavior. One groundbreaking program, known as the Volcanic Ash Advisory Centers, leverages these technologies to predict how ash clouds will drift. These predictions are essential for air travel safety and help communities prepare for possible fallout. As we look toward the future, the integration of these technologies could be the game changer we need. By harnessing the power of AI, drones, and machine learning, we stand on the brink of a new era in volcanic research. The question emerges, what exciting discoveries lie ahead in our quest to understand these powerful natural phenomena? As we embrace innovation, the possibilities are limitless, and the stakes have never been higher. Throughout history, we often overlook how volcanic eruptions have dramatically altered civilizations. One of the most striking examples is the eruption that occurred in 79 AD at Mount Vesuvius, which buried the Roman cities of Pompeii and Herculaneum under a thick blanket of ash. But the devastation didn't stop there. This catastrophic event had long-term repercussions on the Roman Empire. As ash spewed into the atmosphere, it darkened the skies, affecting temperatures and agricultural productivity for years to come. Scientists believe that the ash fallout from Vesuvius led to crop failures across the region, which contributed to food shortages and, ultimately, social unrest. As we delve deeper into the story of Vesuvius, let's also consider the aftermath, how such eruptions served to reshape human development and financial stability. Shockingly, the aftermath even saw the rise of new belief systems as people sought reasons for divine retribution in the wake of natural disasters. Vesuvius stands as a poignant reminder that the Earth can be unpredictable, transforming landscapes and cultures in mere moments. But what if such a cataclysmic event were to happen again, not just in a localized area, but on a scale that could threaten global civilization? Let's dive into the potential of eruptions that could once again unleash horror upon humanity. While most of us are familiar with the major players like Yellowstone and Vesuvius, our planet is dotted with lesser-known volcanoes that harbor immense destructive potential. One such volcano is Mount Toba in Indonesia. Over 74,000 years ago, Toba erupted in the world's largest volcanic event, leading to a volcanic winter that may have decimated the human population. Estimates suggest that as much as 90% of humanity could have perished due to the dramatic climate change caused by this eruption. It is believed that the ash spewed into the atmosphere caused global temperatures to drop by several degrees, disrupting ecosystems and food supplies. The eruption also left a massive caldera that stretches over 100 kilometers wide, serving as a constant reminder of its catastrophic power. Scientists are now studying Toba and similar volcanoes to understand their threats better. Another volcano of concern is La Garita caldera in Colorado, with the potential to produce an eruption on par with Toba's. Experts argue that ancient eruptions leave behind clues we can analyze. Significant ignimbrites, for example, give us insight into the catastrophic past. By examining these lesser-known volcanoes, we can prepare for future risks that loiter in the shadows. As we look at volcanoes that could end civilization, we must consider the human element in this narrative. Are we truly prepared for the ramifications of a major volcanic eruption? Sociedades around volcanic regions often create a false sense of security and may not realize the vulnerability they face. Take the Philippines, for example, where the residents of Taal Volcano live in close proximity to one of the most dangerous volcanoes on Earth. Despite previous eruptions, many have chosen to stay due to economic and cultural ties to the land. This phenomenon, referred to as volcanic resilience, raises several pressing questions. Can we prioritize risk management without displacing communities? What happens when governments cannot fund evacuation plans? We must also examine the psychological impact of living in the shadow of such dangers. The mental toll can be significant, leading to anxiety and a sense of hopelessness. Research indicates that communities that engage in preparedness training can significantly increase their resilience. However, there are limits to preparedness. The reality is, if certain supervolcanoes erupt, entire regions may be rendered uninhabitable, and the global infrastructure could crumble. Our societies must prepare for these possibilities, building contingency plans that account for both physical and mental resilience. In April 1815, Mount Tambora unleashed a cataclysmic eruption that would become one of the most significant volcanic events in recorded history. This eruption, which occurred on the Indonesian island of Sumbawa, not only altered the landscape but also had far-reaching global effects. The eruption itself was colossal, expelling an estimated 160 cubic kilometers of ash into the atmosphere, making it one of the largest eruptions of the last 10,000 years. Over 71,000 people lost their lives directly due to the eruption and the resulting tsunamis. However, the consequences extended far beyond the immediate devastation. The ash clouds spread around the globe, blocking sunlight and leading to what was later termed the year without a summer in 1816. Crops failed in North America and Europe, leading to widespread famine and social unrest. The impact on agriculture was profound. It is estimated that harvests dropped by as much as 90% in some regions. This led to food riots and heightened tensions across Europe, contributing to the political upheaval in the years that followed. Researchers have studied the eruption's cooling effects, noting that global temperatures dropped by about 1.3 degrees Celsius. This incident serves as a stark reminder of how interconnected our climate is with volcanic activity. It also highlighted the fragility of human agriculture when faced with natural disasters. In 1816, the cold summer triggered an outbreak of typhus in Europe, taking countless additional lives. These events collectively demonstrate how a singular volcanic event can have cascading effects across the globe, raising questions about our preparedness for similar eruptions in the future. What if another eruption of this magnitude were to happen today? Would humanity be ready to face the consequences? Today, scientists study Mount Tambora closely, not just for its geological significance but for the insights it offers into potential future eruptions. The lessons of 1815 remind us that we live in a world where volcanic forces can dramatically reshape our existence. The ghost of Mount Tambora continues to loom large in volcanic studies, sparking debates about climate change, food security, and human resilience. As climate patterns shift and volcanic activity fluctuates, the Tambora eruption serves as both a historical warning and a focal point for future research. Iceland is a land of fire and ice, a place where the raw power of nature is on full display. Beneath its picturesque landscapes lie some of the most active and volatile volcanoes on Earth. While we often admire the breathtaking eruptions of Eyjafjallajökull, responsible for the 2010 air travel chaos, there are far more significant threats lurking beneath the ice. One such threat is Katla, a massive volcano that last erupted in 1918. Katla is not just any volcano, it has a history of explosive eruptions that could rival Eyjafjallajökull. Katla's eruptions can release vast amounts of ash and volcanic gases, similar to the catastrophic events of Mount Tambora, leading to noxious fallout. And then there's the risk of glacial melt. A volcanic eruption beneath the glacier could lead to flooding and lahars, rapidly flowing mixtures of volcanic debris and water. Scientists estimate that Katla could erupt again within the next few decades, given its historical patterns. The implications of a Katla eruption would not be limited to Iceland alone. The ash clouds could disrupt air traffic across Europe and beyond, just as Eyjafjallajökull did in 2010 but on a far larger scale. And the broader climatic impacts of such an eruption could alter weather patterns in the northern hemisphere. Current models used by volcanologists show that Katla's eruptions have consistently occurred every 40 to 80 years, making it overdue by geological standards. But it's not just Katla. Other Icelandic volcanoes, such as Hekla and Grímsvötn, also pose serious threats due to their explosive histories and potential for large-scale eruptions. What is both fascinating and terrifying about Icelandic volcanoes is their duality of beauty and menace. While many tourists flock to see these natural wonders, they remain blissfully unaware of the potential dangers. As scientists continue to monitor seismic activities and improve eruption predictions, the question looms larger: are we truly ready for the next big eruption in Iceland? How will society respond when faced with such a powerful force of nature? As history has taught us, the impact of volcanic events can ripple across nations, affecting economies, politics, and human lives. When we think of catastrophic volcanoes, our minds often drift to the Yellowstone supervolcano or Mount Vesuvius. However, many lesser-known volcanic systems around the globe hold the same potential for destruction, threatening the lives of millions and potentially ending civilization as we know it. Today, we will explore some of these hidden giants that could erupt with tremendous consequences. One such volcano is Toba, located in present-day Indonesia. Toba is notorious for its cataclysmic eruption approximately 74,000 years ago, which is believed to have caused a volcanic winter. This eruption was so massive that it ejected an estimated 2,800 cubic kilometers of ash and resulted in a dramatic drop in global temperatures. In fact, The Toba eruption is thought to have reduced the human population to a mere thousands of individuals, as our ancestors struggled to survive in a drastically altered environment. Scientists still study the impact of this supereruption, both to understand its historical consequences and to evaluate the present risks it poses. Another potential threat lies in the heart of Africa, at the Nyiragongo volcano. With its lava lake, Nyiragongo is visually stunning yet deadly. In 2002, a fissure opened on the volcano's flank, sending rivers of lava racing towards the city of Goma, resulting in the evacuation of 400,000 residents. While the lava flow was mercifully slow, the potential for a more catastrophic eruption looms, threatening the densely populated regions surrounding it. Next on our exploration is the Long Valley caldera in California, which has remained relatively quiet since its last significant eruption over 700,000 years ago. However, with scientists noting increased seismic activity and potential unrest, this supervolcano has many experts worried. Unpredictable behavior of calderas can catch even the most experienced volcanologists off guard. Meanwhile, the Campanian volcanic arc in Italy houses several volcanoes that could erupt simultaneously, leading to widespread devastation. Therefore, understanding these lesser-known volcanic systems can give us critical insights into their potential threats. In addition to Toba, Nyiragongo, and Long Valley, we must also consider the potential impact of the Santorini volcano in Greece. This volcano, famous for its Minoan eruption around 1600 BC, had effects that rippled across the Aegean Sea and led to the decline of the Minoan civilization. The ash fallout affected agriculture, leading to disastrous consequences for the local population. The historical repercussions of Santorini serve as a warning about the socio-economic impact of volcanic eruptions. As we reflect on these lesser-known volcanoes, it's crucial to remember that they could all leave a devastating mark on human history once again. With this knowledge, one can't help but wonder, what lessons can we learn from the past to mitigate future threats? As we dive deeper into the unpredictable nature of volcanoes, our understanding must improve, and our awareness must heighten. In the next chapter, we will consider the human element, how societies have adapted to living in volcanic regions and the strategies they employ to protect themselves against potential calamities. Volcanoes don't just impact the landscape, they fundamentally influence the societies that thrive in their shadows. As we explore the interaction between communities and volcanoes, we uncover vulnerabilities that may determine the fate of millions. Through history, civilizations have risen and fallen in the face of volcanic eruptions. Take the island of Montserrat, for instance. The Soufriere Hills volcano began a series of eruptions in 1995 that forced the evacuation of two-thirds of the island's population. Homes and livelihoods were destroyed, and the island, once thriving, became a shadow of its former self. Families were torn apart, forced to adapt to life as displaced people, facing cultural and financial upheaval. This eruption not only transformed Montserrat physically but also left a lasting psychological impact. Communities grappling with trauma show us how volcanic eruptions extend beyond physical destruction. Another poignant example is the eruption of Mount St. Helens in 1980. This event resulted in 57 fatalities and led to economic devastation in the surrounding regions. The ash fallout wreaked havoc on agriculture, forestry, and the local economy,